All right. So this section is very short and very something that you've already done. We're dealing with, in section 2.8, with distance, midpoint formula, and circles. So we begin with the distance formula, where the distance formula is simply the square root of x2 minus x1 squared plus y2 minus y1 squared. And so in example 1, they simply give you the directive. It says find the distance between, then they give you the point -1, 4 and 3, -2. And then they want you to express this in simplest form and radical form. They also want you to round it to 2 decimals. All right, so we begin with this, and in this case we're going to say distance is equal to the square root, given our 2 points, where we're going to use 3 minus -1, all of that squared, plus -2 minus 4 squared. You end up with distance is equal to the square root of 52. Be careful with 52 because there's a perfect root in there. And we know that distance is equivalent to 4 times 13, which is the square root of 52. Which means that this simplified version is 2 square root 13. Or in decimal form, 7.21. There's your 2 decimals. It's that simple. My recommendation, as always, is to label. So if I label, I would say, let's go with x1, y1, and x2, y2 as a helpful hint how to get that answer. The second concept in this chapter is midpoint. And so when we look at this, we're going to look at the midpoint formula, which is in essence x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And so your question in example 2, we have find the midpoint of the line segment with endpoints and they're going to give you 1, -6 and -8, -4. So we begin by substitution. So the midpoint in our example will be 1 plus -8 divided by 2, comma, -6 plus -4 divided by 2. Again, I always encourage you to label x1, y1, x2, y2. And follow the color code because it's as simple as here's your 1, here's your -8. We're adding them together, so there's your -8, there's your 1. And again, the y is -6, -4. We're adding them together. There's your -6, -4. 2 is constant. So your final answer for this one will be a fraction -7/2, comma, -5. And yes, this is -3.5, comma, -5. So you can write them respectively in either way. All right. Remember, this is a video. You can pause and move it forward as you need. So example 3, we're now talking about circles. And so the general formulas that you're going to need here, or the general formula, in this case, it's actually referred to as the standard, my apologies, standard formula of a circle, or actually of the equation of a circle. And so very simple, it's x minus h squared plus y minus k squared, and this is equal to r squared. So in example 3, the question says, it says write the standard form. Oh my goodness, hang on a second. I'm talking and writing the same thing. Hang on. Okay, so write the standard form of the equation of the circle with center. So because the center is at the origin, h and k are both 0. They're not existent. And it says and radius equal to 2. So in essence, when you do the formula, it's x minus 0 squared plus y minus 0 squared, and that's equal to 2 squared. When you condense this, this becomes x squared plus y squared is equal to 4. All right. It's that simple. Okay, in example 4, we're no longer, the center of the circle is no longer 0, 0. The center is going to be a different coordinate pair. So this says write the standard form of the equation of the circle with center -2, 3 and radius 4. Okay, now watch, it's the same process. So it's x minus h, h happens to be -2, and all of that is squared, plus y, in this case y stays, it will be a negative because it's a minus plus, plus minus is a product, is always a negative. And the radius is 4, so 4 squared. Your final answer here becomes x plus 2, because remember double negatives add up as a positive, and then that's squared, plus y minus 3 squared is equal to 16, and that's it. All right, example 5. All right, in example 5, it says using the standard form Okay, so using a standard form of a circle to graph. And so they're going to start us with x minus 2 squared plus y plus 4 squared is equal to 9. So the center is 2, negative 4. Remember, the signs will always be the opposite of what you see here. And because the radius is going to be equal to the square root of 9, our answer here is 3. Always the positive. Remember, distance is always positive. Since I know that that is, let's see here. So we have a center. When this is 2, this goes down 1, 2, 3, 4. So this is my center. If my radius is 3, I'm going to go up 1, 2, 3. I'm going to come over 1, 2, and 3. I'm going to go down 1, 2, and 3. And I'm going to go over 1, 2, and 3. And so that gives me the drawing. Okay, now it's not perfect because obviously I'm not drawing this. But if I show you this on Desmos, you'll see the connection right away. Okay, so if I go to Desmos, I'm going to try to graph this. Let me see if it'll let me do it. So we know that we have x minus 2 squared, and if I go over plus, and this is parentheses, this will be y plus 4 raised to the second, and this should equal 9. Let me see. There you go. Boom. There's your circle. You got some major points there to help you. You can also see the domain and range very easily. You can see the domain. The domain is all x values. So you see this is lining up with the 1, negative 1. So negative 1 to positive 5 is my domain. And if I look at the range, it's from negative 7 all the way up to negative 1. Done. So I've answered the domain and range. I've drawn it. And I've expressed it as a value. All right, let's look at the last example. And like I said, this chapter is very easy and it should serve as a review more so than a new lesson. It happens to be a new lesson. Okay, no big deal. It's a new lesson. You learned it. Done. So we're talking about the general form of the equation of a circle and so we have x squared plus y squared plus, oh my goodness, plus d of x plus e of y plus f is equal to 0. Okay, it looks ridiculous, but it's actually quite easy. What you're going to want to do in this example, this is example 6, is we're going to convert this general equation to standard form. So we're going to go to from general to standard. All right, and this is general form up here. Standard form was what we've been working with. So they want us to write in standard form and graph okay, and they're giving us x squared plus y squared plus 4x minus 6y minus 23 equal to 0. And so if you recall and follow these steps, I think you'll be in fabulous shape. So first thing we're going to do is the x's, and notice that I'm grabbing the sign. those two come together. The y's, those two come together. And we're going to do what's called completing the square once we do that. So step one is I'm going to get this 23 and I'm going to move it to the other side of that equal to sign. So it cancels. Next step, I'm going to group x squared plus 4x plus y squared minus 6y. And we know that this is now equal to 23. So that's all I've done so far. What I need you to remember is that when you have an equation, ax squared plus bx plus c, a quadratic basically, that this c term is b divided by 2 n squared. That's what gives us a perfect trinomial. So if I were to take this term, the 4, divided by 2, which is 2, and square it, I get plus 4. I come over here for the y. If I take the negative 6 and I divide it by 2 and I square it, negative 6 divided by 2 is negative 3. Negative 3 squared is plus 9. But I also want you to notice that because I added these two values here, I have to bring them over here and say, okay, plus 4 plus 9 on the right-hand side of the equation, which is this side. So now I can collapse this, so this becomes x plus 2 squared plus this becomes y minus 3 squared, and this is equal to 36. So in essence, I have the center at negative 2, positive 3, and my radius equal to 6. And that's what we're trying to do in that example. Okay? So any questions you may have beyond this, we discussed in class, so ask me during office hours. And there you go.